Okay, we're back with double angle formulas. So we're able to use double angle formulas to find exact values. So be prepared to do that like we did in the last couple videos with sum, difference, and half angle. But now I want to focus a little bit more on solving equations. So when we're solving equations, we're trying to unlock this puzzle of how we can get theta evaluated without a calculator. Okay, so it's kind of fun. So we're going to look at this one. It's a pretty simple one, but it's a good start. So what we're going to do is we're going to see that the problem here is this 2 theta that's we're dealing with. So just like in college algebra, when we had like an x squared and an x, we couldn't compare those. They weren't like terms. So same thing with 2 theta and theta. Remember that that's an argument in there, and we can't take that 2 out. We need to figure out what that is, right? And there's a lot of places that sine and cosine are equal to each other because they're basically the same function, just moved, right? Okay, so what we're going to do is the same thing we always do with these formulas, is we're going to see one side of the formula, the left side in this case, and then I'm going to write the right side instead. So I'm going to take that equation, and I want it to look like this instead. So I'm going to go find sine's double angle formula here at the top, and I'm going to take the left side and I'm going to write it like that instead. So now the goal here is to unlock the puzzle, okay? So what we're going to do first is we're going to subtract cosine from both sides. And the reason I'm doing that is because I see that I have this common factor of cosine if I do that, right? So that's the strategy. That's why I wanted to try it. And trust me, sometimes you're going to try stuff and it is not going to work, and that is okay. If you eliminate theta, you've done something wrong because we can't solve for it, right? So never eliminate theta. Make sure you have a theta to solve for. Okay, so now what we're going to do is we're going to undistribute the cosine. So we're going to take this cosine out of here. We're going to undistribute that. And then what we're going to be left with on the right here is this. So check my math. Make sure I'm doing it right here. And just go parentheses happy so you know where this is coming from. All that is now my left side. Now, the cool thing about this is, just like with quadratics, if I can make one of these parentheses equal 0, the whole left side does. So what we have is we have some power. So what we're going to do is we're going to set both of those chunks equal to the right side. So I want to set that chunk equal to the right side, and I want to set this chunk equal to the right side. Okay, then I'm going to evaluate like we always do. So cosine at theta, what would make cosine at theta equal 0? Well, we have two places that could happen on cosine's domain, and those are those two funky spots on the graph where we get x-intercepts, right? So then this one's a little more complicated, but man, we're studs at algebra, so we're just going to PEMDAS this guy backwards, and we're going to add and subtract first. So we do that. Then we'll go ahead and divide that 2 out of there. Remember, what we're trying to do is unleash theta. So we got to get the function alone, just like we always do. So now we can evaluate sine at 1/2. This happens at 2 triangles on our unit circle, right? So that happens, ooh, that one got ugly. So that happens at these 2 triangles on our unit circle. Both of these guys are 30 degrees, right? So the first one there is just our basic one. So remember, if you're dividing by 6, it's a 30. So that's 30 degrees. And then if we're 130 short of a full pi, then we must be 1 short. So instead of 6, we have 5. So what we have here is 4 answers on our domain for this equation. So theta equals all 4 of these answers, okay? Remember, we're solving on the entire domain of the unit circle. So we got to get all of the answers. So many times there are going to be 4 answers. Sometimes there's 2. But man, if it's sine or cosine, we're going to have a relationship like this. But if it's tangent, we're going to have one of these. Oop, bad drawing, right? We're going to have, so watch your sign with tangent like always because things get weird, okay? So good luck. If you need help with this, just holler.